The rate of enzyme activity is affected by temperature, pH, and other factors. We can plan an investigation to find out how pH affects the rate of enzyme activity using an enzyme called amylase. Amylase is a carbohydrase enzyme that breaks down long chains of starch into smaller, simpler sugar molecules. It's found in saliva, and it's also produced by the pancreas. We can investigate amylase activity using this equipment. We add a solution of starch to a beaker, add amylase enzyme, and a pH buffer. This keeps the solution at a particular pH, such as pH 5. We also place the beaker in a water bath to keep it at a constant temperature, so we can be sure that temperature isn't affecting the enzyme's activity. Every 30 seconds, we take a sample of the enzyme and starch solution and we add it to a spotting tile. We then add a few drops of iodine. If starch is present in the solution, it will turn blue-black. We keep taking samples every 30 seconds and testing them with iodine. Over time, as the amylase breaks down the starch, there will be less and less starch left, so it will turn less blue-black. Eventually, the mixture will stop turning blue-black when iodine is added and it will remain brown instead. This means all the starch has been digested by the amylase. We measure the time taken for the solution to stop turning blue-black. This is our dependent variable. The shorter the time to stop going blue-black, or the fewer wells it takes to stay brown, the more quickly the amylase is working. We repeat the same process, but with a new beaker of amylase and starch, using a different pH buffer, such as pH 6 or pH 7. pH is our independent variable. The shorter the time taken to stop turning blue-black, the faster the starch is being digested, so the faster the amylase is working. The pH that takes the shortest time to stop turning blue-black is the optimum pH for amylase. This is the pH at which it works best, which is where the rate of enzyme activity is highest. Above or below the optimum pH, the rate of activity decreases because enzymes are denatured. Different enzymes have different optimum pHs depending on the environment they're found in, such as the stomach or the intestine, and what the pH is like there. To make sure our results are reliable, it's a good idea to repeat at least 3 times for each pH, and to calculate a mean for each pH. We need to make sure the temperature stays the same throughout the experiment, and we do that using the water bath. And we need to make sure the concentration and volume of starch solution stay the same as well. These are our control variables. Here are some practice questions for you to try. Pause the video and give them a go.